Today we are going to discuss about implementation of a queue using linked list. Queue is a waiting line like a line of people waiting to purchase tickets or a line of people waiting to use ATM. The first person who entered into queue will get served first. So queue is a first in first out list. Queue is an ordered collection of data items into which elements are inserted from one end called rear end and elements are deleted from the other end called front end. Queue can be implemented using arrays and using linked lists. Now we are going to discuss about implementation of queue using a linked list. Normally, the name of a linked list is pointing to first node of a linked list. But in a queue, we need to maintain two ends. One is front end, the other end is rear end. So see here, there is a list of nodes. It is a linked list. Pointer front is pointing to first node. Pointer rear is pointing to last node of a linked list. So there are two pointers, one pointing to first node of the linked list and the other pointing to last node of the linked list. So to implement a linked list, we need to have a structure of a node. Node contains two parts. One is data part, the other is address of next node. Address of next node. So see here, every node contains two parts, node 1, node 2, node 3, node 4. Every node contains two parts. One is data part, the other is address of next node. Data, address, data, address, data, address. So first node contains some value. It is having address of next node. It means we can move from first node to second node. Then second node is having some data. It knows address of third node. Third node has some value and it knows address of fourth node. Fourth node is having some value and it is not having any address, indicating that it is last node. Last node is rear and first node is front. So first node is pointed by a pointer front, last node is pointed by a pointer rear. So we need to define a structure like this struct node which is having two members, data and address of next node. Data and address. Asterisk next means it is a pointer which holds address of next node. So node is a structure consisting of two members which holds data and address of next node. Now we can define a queue using node type identifier. What is node type? Node type is a type which is equivalent to struct node. What is struct node? It contains two members. So front is a node type variable, rear is a node type variable. So front contains data and address of next node, rear contains data and address of next node. So front is pointed to some node and rear is pointed to some other node. Let me explain how to insert nodes into a queue using linked list. Initially, we assume that the queue is null or empty queue. So linked list is empty. There are no nodes in the linked list. First assumption is initialization is empty queue. So queue should contain a linked list. First node pointed by front, last node pointed by rear. So when there are no nodes in the linked list, it is empty list. So front is null, rear is null. So there are two pointers. One is front, the other is rear. Front is pointed to null, rear is pointed to null. So which indicates that there are no nodes, which is nothing but initialization of queue using linked list. So we are using a linked list to represent a queue where there are no nodes. When there are no nodes, no pointers exist. So front is null, rear is null. Then you wanted to insert a node insert node 10. So create a node with information 10. We are inserting first node into the linked list. So linked list may contain only one node, that is the first node and that is the last node. So the same pointer is pointed by both front and rear. See here, we have created a node with information 10 as we wanted to create a node with information 10. Front is pointed to that node and rear is also pointed to that node. That is the first node and that is the last node. See, the next of this node is null, indicating that it is the last node. Front is pointed to first node and rear is pointing to last node because there is only one node. That is first node, that is last node. Again, you wanted to insert one more node, insert 20. Now we are going to insert a node. Node will be inserted at rear end of the linked list or queue. So there is a queue which is having two ends, front and rear end. Whenever we wanted to insert elements, new element will be inserted at rear end. See here, first node is 10. Second node, the new node is inserted at the end and that becomes rear. Now, linked list contains two nodes. First node is pointed by front, second node is pointed by rear. Last node, that new node. Next, again insert one more node. No, insert 30. Now, see, in 30 is inserted after rear and rear moves to last node. Now, see, 10, 20, 30. There are three nodes. First node is 10, which is pointed by front node. Last node is 30, which is pointed by rear node. So, it is a linked list and pointed by two pointers, one pointing to first node, the other pointing to rear node, indicating that this is front end and this is rear end. Again, you wanted to insert one more node, 40. So node with information 40 is added as last node and that becomes end of the linked list or rear end. See here, there are four nodes. Every time new node is inserted at the end, new node is inserted at the end and that becomes rear end. So a linked list can be converted as a queue by using two pointers, one pointing to the first node and the other pointing to last node. The first point, the pointer pointing to first node is said to be front end and the pointer pointing to last node is said to be rear. So a linked list with the help of two pointers, we assume that it is a queue. Then deleting nodes from a queue in a linked list. Say here we are assuming that a linked list is a queue. There is a linked list. There is a pointer pointing to first node which is said to be front. There is a pointer pointing to last node which is said to be rear. So this is a queue and that is a linked list. We are converting it as a queue because we are maintaining two ends to the list. It is a list. It is having front end, it is having rear end. We are adding nodes at rear end. We are deleting nodes from front end. Suppose you wanted to delete a node. Nodes will be deleted from front end. Suppose in this particular four nodes, if you wanted to delete front node, suppose you wanted to deallocate this node, before deallocation, front will be moved to next node of front. Front is front next. So or next of front. So front will be moved to next node and this node will be removed. So first node is removed and front pointing to next node of front. See here, after deleting front node, the linked list contains only three nodes and front is pointing to 20, rear is pointing to 40. So it is again queue. There is a linked list. First node is pointed by front, last node is pointed by rear. Again you wanted to delete one more node. So here there are three nodes. First node 20, 20 will be removed and front will be moved and pointed to 30. See here, front is pointing to 30, rear is pointing to 40, 30 is first node, 40 is last node and it is a linked list. Linked list having one pointer pointing to first node, another pointer pointing to last node forms a queue. So this is a queue. Again you wanted to delete one more node. When there are two nodes, if you delete a node, suppose if you delete 30 and move front to next node, so this becomes front pointing to 40, rear is also pointing to 40. So a linked list consisting of one node. Linked list consisting of one node. Now you wanted to delete that node also. If you wanted to delete this node, after deleting this node, front and rear becomes null. You can delete this node and even after deletion of this node, there will be no nodes in the linked list. So front pointing to null, rear pointing to null, so that it is empty queue. Empty queue. This becomes empty queue. Empty linked list or empty queue. So a linked list can be used to construct a queue by using two pointers, one pointing to front node, the other pointing to last node. And additions will be performed at rear end and deletions will be performed at front end. This makes a queue. Function to insert a node into a queue using linked list. There is a linked list consisting of three nodes, and front is pointing to first node, rear is pointing to last node. So it forms a queue. Queue means inserting nodes at rear end and deleting nodes from front end. Now we are going to insert element. So assume that we are trying to execute a function insert to insert a value 40. Insert front rear 40. Front and rear are there means it is a queue. We are going to insert 40 into the queue. The queue contains already three nodes. We are going to create a fourth node, and fourth node is going to be added at the end of the linked list, and that becomes rear node. So how this will be performed? Using a function. See here, initially it creates a new node, say T, node type T. T is a temporary node. Allocate memory for T, memory allocation of size of node type. It allocates memory to the node, new node, which is T. T contains two members. One is data, the other is next. Then next one is T data is X. What is X? 40. 40 is passed as X. So X, which is 40. T next is null. So next is null. Then if front is null, no, front is not null. That is, if there is no queue, means if front is null, rear is null, front becomes T, rear becomes T. So this becomes front and this becomes rear. So if there is no queue, the new node that is created becomes first node. Front is pointing to first node and rear is also pointing to first node because it is the last node also. Now it is not this case. So front is not null. So else part will be executed. See here, rear next is T. Rear next is pointing to T. So address of T will be placed in rear next. Then rear is T. So rear moves from here to here. So now this becomes rear. So 40 is the last node, rear is pointing to last node. So linked list is containing four nodes. First node is 10, second node is 20, third node is 30, fourth node is 40. First node is pointed by front pointer, last node is pointed by rear pointer like this. See here, first node is 10, second node is 20, third node is 30, fourth node is 40. 40 is the new node that is we have inserted, and that becomes rear end. So this is a linked list where there are two ends. First end is front end, last end is rear end. So we have successfully added a node at the end of a linked list. Let me explain the function to delete a node from a queue using linked list. Again, there is a linked list. Linked list contains four nodes. It is having two ends. First one end is front end, the other end is rear end. Front end is pointed by pointer front, rear end is pointed by a pointer rear. So it forms a queue. You wanted to delete a node, front end, node from front end will be deleted. So you wanted to delete a node. Say the queue contains some four nodes. I wanted to delete a node. Front node will be removed and second node becomes your front end. So here see there are four nodes 10, 20, 30, 40. Front is pointing to 10. After deleting one node, that is front node, front is moving to second node, that is pointing to node containing 20 like this 20, 30, 40. Front is pointing to first node, rear is pointing to second node. This is a queue after deleting. This is a queue before deleting a node. So how we delete a node using a function, let me explain. So we call delete function. X is equal to delete front comma rear. We are passing front and rear means we are passing a queue. We are passing a queue to the function delete. And this delete function deletes front node and adjusts the front to next node of the front node, and it returns the value of the node deleted to x. So x becomes the value of new node, a value of the node deleted. So first node is 10 with information 10. 10 will be placed in x. So how this performs? Let us assume that there is a pointer t, node type t. T is a pointer. Then if front is null. If front is null means there are no nodes. If there are no nodes, it is an empty queue. It is not possible to remove any node. Suppose if front is equal to rear means if there is only one node, the only node will be removed. The only node will be removed and front and rear becomes null. So T, suppose there is only one node. This is front and this is rear and next is null. Then T is pointing to front node T. Then front is null, and rear is also null. Then T data will be assigned to x. So suppose if data is 10, 10 will be assigned to x, and free T 10 will be removed, node will be removed, and x will be returned. So if there is only one node, after deletion of node, front becomes null, rear becomes null, so that it becomes empty queue. Empty queue. Suppose if there are some number of nodes like this else, right? So front is null means it is not, it is empty. If it is not empty, if it contains only one node, if it contains more than one node. So now here there are more than one nodes. How to delete a node when there are more than one nodes? I am trying to explain now. Now see here, else means here these instructions are to delete a node when there are more than one nodes in a queue. T is equal to front. So T is a pointer pointing to front node. Then front is moved to T next. Front is T next. Front from here it moves to next node. This becomes front node. Then I'm going to delete node with information 10, that is T. Before deleting this, the value of 10, the value of T will be assigned to X. X is equal to T data. So X is 10. Then free T. Free T means deallocating the memory allocated for T. So the node will be deleted. We have X value. We have deleted the first node and adjusted the pointer of front to next node. Now return X. X will be returned. That becomes 10. And your queue becomes a linked list consisting of 3 nodes, which is having 2 ends. Front end is pointing to first node, rear end is pointing to last node. Initially there are 4 nodes, now there are only 3 nodes. Like this, we can delete a node. So while deletion of a node, we have to observe 3 conditions. First condition is, if the queue is empty, it is not possible to remove any elements. If queue contains only one element, after deletion of that node, both front and rear becomes null, that is queue becomes empty. If queue contains more than one nodes, first node will be removed and front will be adjusted to next node, like this. Thank you.